What's up, guys? We're wrapping up the effect devices in Ableton. These are what I would call the utilities, and we're going to start out with the gate. So you know how a compressor, once the audio reaches a certain threshold, you'll get gain reduction. A gate works that once audio reaches a certain threshold, you'll get audio coming through. So it's kind of like reversed. An example would be if you are recording a live band, per se, and you have the vocalist and he's singing or doing whatever he does, you wouldn't want the background of like the drums and like maybe the guitar coming through that microphone. So you'd put in a gate. So I actually have somewhat of a gate in my microphone that I'm talking into right now. So you wouldn't hear necessarily a lot of what's going through Ableton through my speakers. The gate is triggered when my stupid face makes noises. So I'll give you an example here. We have this type of thing right here, and it's pretty dynamic. It's pretty fun. Right? So we have this kind of percussion-y hit here and all of this junk. And we want to get rid of that. We'll pretend that that's like, say your overheads if you're miking up a drum kit, which is a completely other series. So I'll just do this, and we have our threshold. Right? So every time that audio goes above a certain threshold, it'll open up. You can see it visually here. Right? And there's an attack, so it's not so abrupt when the gate does engage. Right, so you'd have a smoother attack for, like, say, background vocals or something like that, just to make everything smoother. Gates are as old as compressors. They're really neat, and that's basically it. Not a whole lot of use for electronic music, but say if you're miking up a drum kit or you have a band going on, a gate is extremely useful, and it cleans up the mix and makes everything sound great. Okay, so we have a utility here. So what utility is basically a utility. You can think of it as a simple gain knob. So say if you have a plugin before it and it's really hot, or it's going over 0, which is fine because of floating point processing. You wouldn't want it to go above 0 into another plugin, so you just put this in here and you'd bring the gain down. So then the next plugin is not working too hard. That's one example to do it. You can mute, and that mutes everything. So there's that. You can isolate left or right, which makes it monaural. You can have just the right. You can swap the left and right. So once you have it on stereo mode, you can pan it left or right. Oops. You can have that. So width. What is width? Well, width is a width of 0 is everything collapsed into its mono stuff. So you have a mono sound when the width is at 0. The stereo width is at 0. Right? When you increase the width to 200, you're only getting the difference between the left and right. So mono sounds is what's similar between the left and right, and like say stereo is like the wide stereo image is what's happening, the difference between the left and right. So you get a wide sound, and that comes into play when you're dealing with mid-side EQing, which we'll get into. Right, that is the wide stereo image, right? You have a left and right speaker, and that's what you use it for. The phase, so what this does is you have left and right signal, right? And you have these little weevily-wavelies, right? Right? When you invert the phase of left or invert the phase of right, what happens is one of these, it gets flipped. So the left channel, the phase is flipped. So you have these two playing kind of upside down, and you get a really weird effect. So when you invert both of them, it kind of goes back to normal. right? So what's happening is you're getting a different phase from each speaker, and it's kind of canceling it out, and that's why it kind of makes you feel dizzy. All right, so, oh yeah, another thing. I'll just open up an audio track, and I'll have it received from my synthesizer in. And I'll just bring that up. Right. So, what we have here is we can have something called DC offset. And that's not good most of the time. And what we can do is I'll show you. So we have like this noise floor here, which isn't good. This happens a lot with like vintage gear. And the phase can be not directly at 0. It can be moved up. You don't get this with like VSTs and stuff, but you get it with certain pieces of analog gear. So you just turn on DC offset, and this, kills off the range. Or it kills off like the noise floor, and it's really useful for vintage gear that's kind of unpredictable and broken. And yeah, I don't have anything like that to show you with, but I do get some noise through my outboard gear. And that's that. Another thing, okay, we have this, right? We have our spectrum. So this is kind of interesting. We have a readout between 20 hertz to 20,000 hertz. And it shows you what the sound is doing. Right? And you also have the same thing within your EQ8. Right, and it's just it's the readout of what the frequencies are doing. So if you completely high pass something, you lose all bottom. And generally, yeah, it's neat to look at, but you should really be using your ears and trusting your monitors and having high quality monitors. You can have a block, which is the resolution, left and right, and the refresh rate of however many milliseconds you want, and the average. And you can have a line graph and select max. You could double click it and have a very high quality readout. And you can find like problem areas and peaks of your sound, and you'd have this on like your stereo master or in a group, and you can see what's going on. Yeah, all right, that's pretty much it for utilities and stuff. All right, have a good one.